go ahead and get started. I just hit the record button, so you should see a quick note letting you know that the session is being recorded. And so welcome to day 2 of our community of practice, assessing and diagnosing unfinished learning in math. Very quickly, once again, my name is Hawkins. I work as a math instructional coach in Washington, D.C. I also work as an educational consultant and consider myself a change agent. A couple of new facts and a new picture. First new fact about me, baseball is my favorite sport. Definitely a diehard Nationals fan. And this is a picture of my newest daughter, Adiel. And so last time, if you remember, the picture I had up was of my oldest daughter, my wife, and myself. It was a Christmas photo. So I figured it made a lot of sense just to share with you all just the progression that's happening in my household, just so you get to know me a little bit better. So there's a picture of Adiel. And then next time, my hope is to find a great big sister, little sister picture and then be able to post that. But I definitely got to get big oldest daughter's approval first. So I got to keep working on taking those pictures. And so with that being said, we're going to jump right in. Thank you, Kathy, for your kind words. I definitely appreciate it. I'm going to go ahead and drop the link in the chat one more time. Either link will take you to the same location. Take a moment to make a copy so you can access today's materials. And while you are doing that, just a couple of housekeeping notes. Our norms are the same as last time. Just as best as possible, keep your camera on and stay in the moment and be present as much as possible. As it relates to audio, if you're not speaking, stay on mute. That way we avoid any background noise. Definitely some of you are in the same room. So if you have multiple devices, definitely recommend muting one device. That way, if someone does come off mute, you don't get that weird echo sound. When we're in breakout rooms, we only have one breakout room session that'll happen towards the end of our time together. So definitely engage with others during the breakout room. We're going to use the chat often, like we always do. We're about to use it in a moment. So go ahead and make sure, yes, like my smallest dog barking in the background, exactly. So the biggest dog is outside because it's actually about 65 degrees in our area today. I heard you guys had like about 4 feet of snow, but yesterday was about 50, somewhere around there. So decent weather. So like a heat wave almost. So one dog is outside sunbathing. One dog is barking at leaves or whatever is running past the house. And the other one's probably just chilling with my daughter, the oldest one. So very quickly, you have the materials. So we are ready to go. So this will be our first opportunity to leverage the chat. And so on the screen, you have 4 images and there's a question. So which image best captures your experience in K-12 mathematics? I'm gonna give you a little time to process which one of these 4 pictures. What I would like you to do is go ahead, select a picture and then give a brief explanation as to why you selected that picture. I'm gonna put a minute on the clock and then after a minute, I'm gonna ask you all to hit return so you can start submitting your answers in the chat. I'll do a little bit of narration, and then we will jump into our work for today. All right, go ahead and start dropping your responses in the chat. So I'm liking some of the responses that I see in the chat. Couple of people saying that to be successful in mathematics, there was a lot of hard work. Definitely want to, all four could represent, an experience given at a given time, but focus on the successes. So leaning in on number two. Um, Someone connected with number three, given the fact that, upper level mathematics was a challenge for them. So definitely see, and then we love the cute dog. So hopefully, with that being said, we see that don't say you're bad at math. You just didn't have the greatest instruction in math. That's the issue. So because we're all good mathematicians, because we all manage to navigate our lives some way, shape, or form, and we don't, wind up spending all our money at the first couple of days of each and every month. So we're doing something right. So you're definitely not bad at math. It just, challenges, which is, makes you a better person. But part of the reason why we ask this question is because your own lived experience in K to 12 mathematics has informed how you provide instruction or how you lead, depending on, where your sphere of influence is. And so I know, like, for myself, one of the things that I was a mix between two and three. And those three moments were not really frustration around like the challenging content, but more around frustration around teachers who didn't put in that time and effort to actually teach us the content that wasn't like scripted in the book. So my experience was often that we would get the same thing that's in the lesson regurgitated to us by the teacher, nothing new, nothing was added. And then when we got to a problem or a challenge question that was out that forced us to think outside the box and we asked the teachers for support, they were very limited in their response because they hadn't done the work themselves. They hadn't done that planning. They hadn't thought through some of our potential misconceptions. It was like either you got it or you don't. So we know that that also plays a role in educators, response to providing that educational experience for students. And as we think about unfinished learning, what we hope is that some of the experiences and challenges that you face, you want to try to mitigate those for the students that you serve. And some of those great moments like number two or number four, you want to try to replicate those for students so they can have those positive experiences. So when they say things like, I was bad in math, it's because you had all these bad experiences in math. So we want to try to push for positive experiences and positive outlooks on K to 12 learning for our students that we serve. All right. So transitioning slightly back to the self-assessment that we asked you all to complete prior to today's session. Just want to do a moment of reflective time around the second question. We want to lean in on this idea of teachers and staff having strong content knowledge, and that's going to frame a lot of our work that we're going to do here today. I'll give you a moment. The question is on the screen. Just think about the response that you provided based on where you currently think your staff is as it relates to the math content that they teach. Excuse me. All right. So as you think about your staff and your teachers and your support staff and where they are in their content knowledge, that theme will come back multiple times as we go through our learning here today. So here is our learning at a glance for today. Very quickly, our focus today will be assessing and diagnosing unfinished learning in mathematics. And what are we doing today and why? And so last time together, we identified the key three actions for acceleration as it relates to students with unfinished learning. And for our work today of diagnosing and assessing unfinished learning in math, we're going to lean in on those first two key actions of understanding and then diagnosing. Our next two sessions, session 3 and session 4, will focus primarily on how do we plan and take action as it relates to core supports within like a tier one idea or concept. So how do we provide supports in the main core math instructional classroom? Then our last session together, we'll focus in on how do we provide that tier 2 or tier 3 support to either small groups or that intensive intervention. Here is our session agenda. We're going to finish up getting started. We're going to jump into our session on deepening understanding of the mathematics that we teach. Then we'll go into diagnosing unfinished learning, and then we will reflect and wrap up for today. So let's go ahead and jump into this section where we're going to focus in on deepening the understanding of the math that we teach. And we start with a quote. I'll give you a second to read the quote before I continue. So this quote speaks to the need for teachers to have and possess a deep content knowledge of the subject matter in which they teach, and more just than the grade level content that they teach. So if we're talking about a fifth grade teacher, a great fifth grade teacher should have deep content knowledge of the fifth grade standards, but also the fourth grade standards and also the sixth grade standards. And the reason why we want them to have that deep understanding is because in order to support students with unfinished learning, they first and foremost have to have a clear understanding of that prior foundational knowledge that students either did not have an opportunity for mastery in those earlier grades, which they will then have to provide that on-ramping to grade level learning. And then also that deep content knowledge will provide them the opportunity to help students make the connection to future learning. So what's going to happen in fifth grade that's going to support students learning grade level content in sixth grade. And so given what we know about, our current state of affairs with the pandemic, what we want to do is push this narrative of teachers having a deep content knowledge. And we also know that understanding is not an on-off switch. So sometimes I know what I'm doing and sometimes I don't. I mean, we've all had experiences where we've seen that type of instruction play out in the classroom, and it's very detrimental to kids. So what we're advocating for, and this goes back to the reflection question I had you think about a moment ago, was what's the percentage of teachers in your building have that strong or deep content and math knowledge? And we're going to talk about how do we support and develop that content knowledge amongst your team of teachers. And so we're going to lean and think about our academy, Brightwood Academy, which was our case study we looked at last time as a tale of two schools. And I introduced you to Ms. Hutchins. So Ms. Hutchins, this is her first year teaching seventh grade math. Before that, she used to teach social studies in the high school level. And so this standard that we're looking at is for an upcoming unit on solving multi-step equations that involve rational numbers. And so before we jump into digging into the standard, I just want to make a quick note. And so as we move throughout this sequence of learning, what we've done in terms of our design is we've laid out the Common Core standard language like 7EEB4.A, because that way, if you're navigating other resources, and there'll be a few resources that are outside your state that we're going to introduce to you today. Maybe you're already familiar with it, but either case, we'll learn about them today. The standard approach is for us to use the Common Core tags as for the standards. What I have in parentheses is the standard that closely aligns to this Common Core standard within your state. Okay, and so just want to make a note of that we recognize that there is some slight variance, and so we're going to lift that up, make sure we're clear about that. And so with that being said, we want to walk through a process of what Ms. Hutchins and the seventh grade team at Brightwood Academy, how they go through the process of preparing to teach a lesson preparing to teach a unit that's aligned to this standard. So before we jump in, I'll give you a moment to read through the standards so you have a clear picture of where we're going to go. So this standard is also on the top of page 1 in your note catcher, and you'll also see it reoccurring several times throughout your note catcher throughout the day. And so what we're going to do now that we know a little background about Ms. Hutchins, we also know the standard that the Brightwood 7th grade team is going to unpack. Excuse me. What we're going to do now is we're going to spend some time going through Mrs. Hutchins and the team's standards analysis case study. And so to do that, I would like for you to turn to pages 2, 3, 4, and 5 within your note catcher. Okay. So what you'll see on the screen, this is the top of page 2. And what I would like for you to do is the following. I want you to read through the standards analysis case study. This case study also includes a conversation, a transcript of the conversation that the PLC had as they talked about this standard. And then as you're reading, I want you to take notes around what are some of the things that you notice and what are some of the things that you wonder about what the team is doing as it relates to unpacking the standard and as it relates to the conversation that's happening within the amongst the team. So I will put 5 minutes on the clock and then we'll check back in and we'll leverage the chat to respond first about what are some of the things that we notice and then what are some of the things that we wonder. take about 45 more seconds to finish up, and then we'll start responding in the chat to what do we notice and what are some of the things that we wonder. All right, so welcome back as we come back together from analyzing that case study about Ms. Hutchins and the seventh grade team. Let's go ahead and take a minute or so to drop in the chat. What are some of the things that you either notice or what are some of the things that you wonder about Mrs. Hutchins' analysis of the standard 7EE.B.4A? So there's a question about what's the sprint and what is a tape diagram. So a sprint is part of the Engage New York curriculum, where it's like a quick procedure practice fluency drill for students to engage in. It usually has about 40 questions, like quick problems. So maybe it could be around adding integers, for example. And the way they're structured is there are two of them per A and B. And the idea is you have students walk through and in a minute, knock out as many problems as they can. The teacher engages in a conversation where he or she walks the students through the solutions to the sprint. All the time, there's a pattern that students can identify of how to quickly answer some of the questions. And the goal of the sprint is to, however many questions you answer correctly the first time, you're trying to improve upon that number the second time around. So you give them this at bat the first time, you have a conversation, you unpack any misconceptions, then you give them a second go round. And then the idea is students get points or credit for the growth that they've made from one sprint to the other. A tape diagram, very quickly, is a structure that students could use to do a variety of things. You could add, you could subtract, you can multiply. Tape diagram is a model that is introduced to students in first grade, and it kind of lives with them for the remainder of elementary school. And then kind of around sixth grade is when they use it to look at like ratios and proportions. And they also use it a little bit in seventh grade. After seventh grade, it kind of teeters out in most high quality curriculums, but it is a common structure or model that students are familiar with. So oftentimes that's a quick structure to lean back into to provide students access. So that was Dave's wonder about those two things. And then anybody else with some notice and things they noticed that was happening with the team or any other things that they wonder. But great question, Dave, because I could see how that could be confusing if you weren't sure. So the conversation became more complicated. It also became more complex. I think what also happened is there was nuance that a novice teacher might not have picked up on that a veteran or experienced teacher who's engaged, who has a deeper content knowledge, was able to share. And so I'm glad you mentioned that, because that's one of the benefits of the PLC, is that collaborative time to support each other and grow and develop as a team. Um, and so someone just mentioned it's a convoluted standard. Can you want to come off mute and elaborate a little bit so we can have a conversation about that? If you're willing to share what you mean about convoluted. Oh, okay. So you mean comparing it to the Nebraska standards? Nebraska standards is more straightforward. Okay. Any other notice or wonders before we transition to the next question? All right. And so I'm gonna hold off on responding to the completely responding to that question, because I don't want to give too much away too early. But I want to come back to that question in a moment. So now I want to look at the second question. So how did the team's discussion of the standards deepen their understanding? So if I could get one or two participants to come off mute and share based on what they read, how did the conversation that the team had deepen the understanding overall of what the standards is expecting students to know and be able to do? Looking for two volunteers to come off mute.
Can you guys hear me?
I can hear you. Yep.
I guess kind of like what we were talking about, like as they, and this is what I've been trying to work with our PLCs too, as we talk about that standard more and unpack it, we start to notice little nuances and how there's a lot of information shoved in there, right? There's a lot of different concepts for students, and it helps new teachers, some of our novice teachers, and some of our veteran teachers too, that pick up on like, hey, let's make sure we use a negative number here, and just those little things that somebody maybe teaching it for the first or second time wouldn't notice.
Okay. Thank you for sharing. Is there someone else that wants to share? I think someone has what I want to say. I just want to hear from you versus you hearing it from me. I know it's in the room. I can feel it.
I don't know if I have what you wanted to share, but I think just some clarification in the discussion about what students should actually know, right? As opposed to like assumptions when you're working on it with a team of teachers. Everybody can walk away with a different sort of takeaway about what kids need to know at the end of it. And so to me, when they're asking questions, like when they're saying, how are they expecting students to compare an arithmetic solution to an algebraic solution? That's going to deepen what teachers know and their ability to teach the standard, which would also help with getting to the point where students can master the standard, as opposed to things being sort of vague.
Okay. So you're definitely on point with close to what I was about to say. I just want to add on very quickly to that. So part of why I didn't want to answer it earlier, because I wanted to hear from other voices in the room. But one thing that's very specific about this standard is this standard covers all three aspects of rigor. So conceptual understanding, procedural skill and fluency, and then also application. And so when a standard covers all three aspects of rigor, it's very robust and it's asking or expecting a lot from students. The other thing that's important is when you see a standard like this is not a standard that's covered in like one or two lessons. This is like a big important standard that's covered over a series of time. And maybe at this one moment in your curriculum, you're may only attending to certain aspects of that standard, but not, or maybe you're touching on all three. But in most cases, when there's a standard that covers all three aspects of rigor, it's going to show up multiple times over the course of that curriculum. So that's one of the things I wanted to mention. Also, there's a lot of language that must be unpacked within this particular standard, which is also why I tried to lay out in detail the different things. So if you look back at the top of page 2, one of the things you'll notice is I've identified like some of the key words, like what are some of the verbs that are taking place or that you see within the standard itself, which gives you some clues about those different aspects of rigor that students are expected to know. The other thing is there's also a few different representations that come out. There's also a couple of methods, and you just lifted up, Monica, about comparing an arithmetic to an algebraic solution. And that concept in and of itself will grow over time, where it just has kids or students solve the problem using, guess and check mathematics, where they're just plugging in numbers and simplifying, to then creating a standard equation and then allowing them to see the connection between the work they did that was a little informal is the exact same structurally work that they did when they created an equation and then went through and solved it. The one last thing I want to mention about this standard in particular is that one key thing, if a novice teacher looks at this standard and they see the words rational numbers, or they look at the unit and see that there are lots of rational numbers as part of the equations that students must solve, there's a tendency for educators to modify those problems and to remove the decimals or fractions and replace them with integers. And so one of the reasons why this standard was selected is because if a teacher does that, what that does is that has lowered the rigor of this actual standard. And what you've done is, in this case, you've actually transformed this standard so it mirrors the 6th grade standard, because that's the 6th grade expectation. And what happens when 6th grade is they transition to then in 7th grade solving those same equations with the rational numbers. And so just want to lift up a couple of those moments and to highlight why those conversations are so important, because those nuances that someone may not be aware of could be detrimental to the learning, to grade level learning for those students if they're working in isolation. And so just wanted to lift a couple of those things up because I thought they were important to hash out. And I hope I kind of clarified a little bit about the standard as a whole. Another thing is that we want to introduce to you some resources from a different state, but that are high quality vetted resources. So the Louisiana believes, or the Louisiana Department of Education has a teacher support toolbox. And a lot of the resources that we're going to use today come directly from this resource. And the reason why we're lifting up this resource is because we know in some situations, there may only be one teacher that's teaching that grade level content. And so they don't have the opportunity to have that sounding board or to have those conversations with other people, the same way we just saw modeled in our case study. And so this is just another resource that will kind of give teachers the insight, or leaders the insight, to support that teacher around those clear aspects of rigor. What are those foundational standards? How they could best support and diagnose unfinished learning for those students. And we're going to see throughout our time today a couple of different resources that are connected to the teacher toolkit on the Louisiana Believes website. And so one of the other things we're trying to hit home here is that in order for a teacher to have that deep content knowledge, we think that the best way for that to happen, of course, is to engage teachers in a professional learning community. And one of the challenges of not having those PLCs is that that teacher does that work in isolation and doesn't have the opportunity to ping ideas off of somebody else. And as a result, we have a couple of quotes from the architects of our Common Core standards that talk about some of the disadvantages that, well, first one talks about the disadvantage that could take place if a teacher doesn't do this work the right way. And then of course we go back to something that we we learned last time as it relates to progressions. So I'll give you a moment to read those quotes before we move on. And so as we talked last time, we know that the structure of the standards were written so that we could lean on the power of the progression. So we could identify foundational skills in prior grades that would give students access to that grade level learning. So we know that's a equity move that we all want to strive to have consistently happen in our classrooms and our schools. So we just wanted to remind you of how important that is to take place. And so what we're going to do now is we're going to spend a little time just looking at those progressions as it relates to this standard. So we're going to do the following. So you have on your note catcher, if you turn to pages 6, 7, and 8, the first thing you have is a breakdown of the standard. It talks about the aspects of rigor, which I've already shared. It talks about some of the mathematical objects, so it does a little unpacking of some of the language within the standard. And then it gives you what is known as a no-show chart. So a no-show chart is when you take a standard and you identify what are some of the things that students must know as to show evidence of mastery of the standard, and then what are some of the actual outcomes that students will show you in their work as evidence of that mastery of the standard. So that's on page 6. And then on pages 7 and 8, what you'll see is you'll see a protocol for learning progressions that the team at Brightwood followed, and then you'll see an exemplar of the diagnostic assessment that Ms. Hutchins will provide to her students, and you'll see the foundational standards. So what I'd like for you to do is take the next 3 minutes and just kind of skim through those before we move on, and then we'll have a moment to respond to the reflection question on the screen. All right, let's come back together. And so there's a reflection question I would like for us to answer, and I'm looking for one or two individuals to come off mute and share their response to this question. So how does this process for uncovering the progression of learning equip Ms. Hutchins to assess and diagnose unfinished learning?
I'll share. So, oops. All right. So, step one, maybe not.
So if you have multiple people in the room, just have them mute their mics so it doesn't pick up the background.
Let's do that. All right. So, step one was sort of identifying that unfinished learning. And as you go through this, you're breaking apart into the prerequisite skills that are needed. And as we identify those prerequisite skills, that allows us to do that just in time sort of content teaching, as opposed to that just in case content teaching we talked about last time.
Mm-hmm.
So I feel like by breaking apart into those pieces, you can identify where the missing chunks best fit in and how to accommodate for any missed learning due to pandemic or whatever.
Got it. Okay. Thank you. I appreciate that. Does anybody else have something they want to add on to what we just heard? All right. I'll take the silence as a no. But one of the things I will notice or direct your attention to is the connection between how they looked at the grade level standard, unpacked it, and looked intently at the standard language. And then they did the exact same thing when they looked at those foundational skills. You see how they broke down the standard language. So that's also a definite important process, because you see the connection of how the foundational standards directly align to how once a student has that access to that foundational standard, they could then engage with grade level work. Just wanted to highlight that for you. I also want to highlight, and I want to say thank you for jumping off mute and sharing with us, but also want to highlight the fact that a resource that we looked at last time was the essential instructional content from your state. And this is another great resource you can use to identify what the level of priority would be for this particular standard or any standard that you're about to teach or instruct students in. A couple of other things that are resources available to you in your state is that if we look at this 7th grade standard and we go back and look at this resource that's provided within the essential instructional content guide, it lifts up that foundational standard of that 6 EEB cluster, that is where the essential learning needs to have happen in order for students to access that grade level work. And so this resource was used in conjunction with the LDOE resource that we see to kind of map out a clear understanding of what specifically within that cluster we need to attack in order to provide that unfinished instruction. One other note is that the resource also lifts up some within grade coherence, specifically thinking about ratios and proportional reasoning. But one of the things it mentions on this slide is how you don't have to re-engage students in ratio and proportional relationships prior to engaging them into this grade level content. So although it's a prerequisite within grade prerequisite, it's not something that has to happen again prior to students engaging in this content. We just want to lift up a couple of different ways to see the importance of leveraging these tools and resources. So that's 2 of the 3 dogs. I do apologize for that. So the key point here is that uncovering the math and progressions within the standards, what it does is it equips us to assess, and accurately diagnose the unfinished learning. And what we're going to do now is we're going to jump into that next piece where we're going to look at the specifics of how we're going to determine that evidence that students are able to provide for us to give us that indication whether they're ready without any support to engage in grade level learning, or if they need some type of scaffold or intervention on our behalf in order to give them that on-ramping to grade level learning. So now we're going to jump into our next session, which is where we're going to focus in to assessing and diagnosing unfinished learning. And so we want to lift up 3 potential key actions to diagnosing unfinished learning. The first is identifying the right diagnostic. So what's that correct tool that's going to give you that evidence that you need to determine whether students need that have that unfinished learning and thus need that intervention. Second, we want to consider what constitutes evidence. And then third, we want to interpret the evidence to then gauge whether or not students are definitely in need of that direct support. Okay. And so these are our 3 steps, and we're going to lean into the first step, which is identify the right diagnostics. And so we're going to lift up a new resource within that teacher toolkit on LDOE, which is called the Eureka acceleration tool. So very quickly, if you're not familiar with the Eureka curriculum, it is organized by modules. Most grades have anywhere from 4 to 7 modules. The younger grades have up to the larger number. And as you get all the way to like Algebra 2, there's only 4 modules. And so within each module, there are topics. And topics usually cover, I would say, anywhere from like 5 to 10 lessons. And so what you'll see is the module has a big arc of learning, and then each of the topics are those big fundamental pieces that bring you back up to the overall arc of learning for that entire module. And within this resource, one of the reasons why we're sharing it with you is because it provides a diagnostic that's aligned to the foundational skills that are most connected to the grade level learning. And so this is a moment where you could take some of the guesswork out, where you could just use some of these resources depending on which grade level that you teach. And so a couple of quick facts about the acceleration tools. They're currently available in grades 4 through 8 and also Algebra 1, and they're aligned to most of the major work topics within each grade level. You may be wondering, what if I don't use the Eureka curriculum or I don't have a grade that has these tools available? What you're going to notice throughout our learning today is the process that we're following is transferable to any curriculum. And so we want you to focus on the key takeaways from the process. And if you're unable to use this resource, identify a resource that allows you to kind of do the same things. And on this next slide, we have a few resources that you could use to pull and identify diagnostics. And so first and foremost, from the high quality curriculum, there's a Eureka Math Equip. One other strategy, which I've definitely would recommend, is once you've identified those prerequisite grade level standards, doing a search within your curriculum for any lessons that are connected to that standard, and then identifying open-ended problems that will give you that evidence of student understanding that you're looking for. If you have access to illustrative mathematics or IM, they have check your readiness moments where you can use those as diagnostics. Also with Achieve the Core, which is the company that created the coherence map, every time you look at one of those any standard on the coherence map, there is some type of assessment that's connected to it. So that could be a great access point. They also have a spot on their website where there's a section called Do Nows for Unfinished Learning that can be sorted by standard. So these are some of the resources that if you're not able to use the resource or the tool that we're going to use today, these are some places where you can get some of these diagnostic assessments from. A couple of quick facts about diagnostics. First and foremost, They are very timely. So they happen at the unit or topic level for each area. So you wouldn't necessarily be able to do like a diagnostic for every single lesson. But what you will be able to do is do a diagnostic for a series of lessons that cover like an overall, like a small arc of learning for within like a unit or, you know, a module, depending on your curriculum. The other great thing about the diagnostic is it must be targeted. So it leans in and zeroes in a focus to those key prerequisite concepts or skills. These diagnostics must also be manageable. So they should not be very long. The diagnostics that we're going to look today, when they address a standard, they cover 3 questions. And the idea behind that is very simple. If a student is able to answer 2 out of 3 questions correctly without any support, then the assumption is they're able to engage in that grade level learning without any intervention. So a 3-question assessment is something very doable. It can be quickly embedded into a current assignment and doesn't take a large amount of time away from instruction, but it gives you a data set that's very manageable as well. And if you think back to what we talked about last time, we recommend you giving like a 2-week window, which gives the teacher a time to administer and unpack the data from the assessment. And last but not least, it's formative. So we want the assessment to focus, we want the assessment for learning and not of learning. So we know you haven't taught this concept or these concepts yet. We just want to give we want to give some clear evidence of where students are so that we can adjust instruction as needed. And it's not based on like perceived readiness that students have. We're going to actually lean in on data to have actual answers to whether or not students are ready for this grade level content. And so very quickly about these assessments and their structure, they're organized into 2 or 3 parts. This one in particular has 4 parts. Like I said earlier, each part only has 3 items, and then each part is also aligned to a foundational standard from a previous grade. So here's a quick reflection question I want you guys to think about before we move on. What opportunities does each item in part C provide for eliciting evidence of student thinking on the prerequisite standards? So on the top of page 9, you have a link in your note catcher that gives you access to the diagnostic assessment. I would like for everyone to click on that link, and then if you could turn to the top of page 3, or the bottom of page 3, excuse me, and page 4, you will see the diagnostic that's aligned to this grade level standard. So I want you to I'm gonna give you about 2 or 3 minutes to access that, and then give you an opportunity to do a quick scan, and then the next activity will give you an opportunity to answer this particular question. So take about 15 more seconds to finish up before we come back together. And like I said, you'll have an opportunity to discuss some of the things that you notice in a few minutes. All right. So we're going to jump into part 2, or the second key action for Diagnose, diagnosing unfinished learning, and that's to consider what constitutes evidence. And so looking at that same tool that you were just analyzing, if you scroll down to page 7, this assessment guide gives you some clear look-fors for what students should be able to do if they're able to answer these questions correctly. Also on the in blue, it also tells you a potential solution for acceleration that you could target to support students from that prior grade level learning. So I'm gonna give you a quick 2 minutes to kind of read through this, so you can take what you did a moment ago, take this, and then it'll help inform what we're gonna do in the next step. So now that you've had a chance to analyze a few of the resources within the acceleration tool, we're going to jump into now identifying an exemplar or creating an exemplar response. So the assessment that you see, remember the assessment's at the bottom, starts at the bottom of page 3 and ends and finishes up on pages 4. And it's part C, questions 7, 8, and 9. Here's what I would like for you to do in the next 5 minutes. So first, I want you to create an exemplar response for one of these items, okay? If you finish early, what I would like for you to do then is if you turn to pages 9, 10, and 11, you'll see some sample student responses. So once you create the exemplar, you'll see some student work samples that you can take a look and begin to analyze, and also see some of the strengths and misconceptions that Ms. Hutchins was able to identify based on the student work samples. What we're going to do after the 5 minutes are up is we're going to jump into breakout rooms where you have an opportunity to just share based on Ms. Hutchins the standards and progression analysis. What are some misconceptions and incomplete understandings that are lifted up as a result of the work that you've just done? So step 1 is going to be create the exemplar response just for one of these items. If you finish before time is up, you can go ahead and start analyzing the student work. Once the 5 minutes are up, I'm gonna give you a few minutes to double check that student work. I'm gonna put you guys in the breakout rooms. Then we will share out as a whole group, and then we'll talk about next steps. So I'm going to go ahead and put 5 minutes on the clock now. All right, let's come back together. So before we jump into breakout rooms, like step 2 in our process is thinking through, like, creating that exemplar response, and then thinking through what are some of those misconceptions or incomplete understandings that might pop up. And so now we're going to jump into our third key action, which is interpreting the evidence. So we're going to take a deep dive into that student work and determine what evidence we can bring out to tell us whether the students are ready to access that grade level learning without any support, or based on their misconceptions, what type of strategic supports can we embed to give them that access to that grade level work. And so if you haven't already done so, I'm gonna give you a few minutes to analyze the student work. And when you're analyzing the student work, we want to think about a couple of things. So what stands out to you about the teacher analysis? So at the bottom of each student work sample, there's a breakdown of what the student strengths are and what their misconceptions are. And then also the other question that I want you all to answer within your breakout rooms in a moment will be, how does the previous work of uncovering the standards and analyzing the learning progressions inform the interpretation of the student work? So when you get in your breakout rooms, I want to give everybody an opportunity to share based on the exemplar that they created, just thinking about what do they notice about the teacher's analysis of the student work as it relates to the problem they unpacked, and then what could they take away from the process that we've done so far that gives you that clear understanding of where to categorize that student work. So 3 minutes to analyze the student work. I'll put you in breakout rooms for about 7 minutes, and then we'll debrief and talk about next steps for about 2 to 3 minutes. So I'm gonna start with the 3 minutes to analyze the student work. All right, so I'm going to go ahead and transition us into breakout rooms. And this is, we're going to focus in on sharing out our exemplar and make some connections to the teacher analysis based on the student work. So I'm opening up the breakout rooms now. All right, so welcome back. I had a chance to jump in every room, and I feel like there's some questions or concerns that I feel like people had that I think we would be beneficial for us to address. And so, just want to just give an opportunity to do like a debrief, and I can share some insight into because there were a bunch of questions. One question was about what's the best way to embed missed learning was one thing I heard within one group, and there is no like one correct answer. I think the best approach is to what I heard in the group was it, as an experienced teacher, you kind of learn the common misconceptions that come up as a consistent basis with students as as you're teaching this concept. So using that knowledge base, you would automatically embed that learning in the lesson because you could help students avoid some of those misconceptions, right? But also, you still want to give these diagnostic assessments because although in your plan you're thinking, how do I support a student who has all the mathematical knowledge they need, but one of their misconception is not going back and reading the problem correctly and setting up the appropriate equation to then solve it correctly and find the correct answer. Or going back and checking their work and matching up the information and their answer and see the reasonableness of their answer as it connects to the scenario. And so one of the things I'm thinking about is, as a teacher with the experience, how you address some of those things. But what you don't know is to the depth of misunderstanding that is present within those individual students, unless you have that diagnostic data. And so you in your toolkit of experience, you have some tools that you already know are in your wheelhouse, but this data gives you the ability to fine tune those skills and be laser focused on where the most critical support is needed to then get kids the ability to access that grade level content. And so I do want to hear from anyone who wants to come off mute and share just some of the conversations and any reflections about how does some of the work that we've talked about today help inform the interpretation of that student work. This was the same group that was just talking in the breakout rooms. I'm convinced. I was there.
A lot of the information that I've worked with is anecdotal interaction with the students one-on-one, which is one of the core things that we've been focusing on this year with engagement and being able to interact. And so the data ends up reflecting what we already learn about our students through working with them. And some of the issue that comes is that you have students that don't understand a concept, but you also have students that um, are on the verge of being so bored with the content that they tend to rush and make mistakes. So you get them on both ends of the spectrum.
Okay, that's very true. One recommendation for that is always embed like error analysis questions where there's already a mistake. And I would then lift up some of those common mistakes that you've seen students make and then have them identify the error, explain why the error is why the mistake is a mistake, and then have them correct it. Because that's one way I've helped support those students who move too quickly because they know how to, for example, solve equations. Like I know the skill, but if I don't take my time and think it through, I make careless mistakes. So how do you help support that? And I think error analysis is one leverage tool that you could use. So like you could even take this diagnostic data and pull a common mistake that students made and then use that as the error analysis question. Say, hey, here's a common mistake. Here's a problem. Johnny solved this equation. There's two mistakes. Identify the mistakes and then go from there. And it'll help students make the connection because, hey, oh, I made this common mistake. Or, I was about to make that mistake, but when I checked my work, I realized this mistake was wrong. So that could then breed a robust conversation that'll help support some of this unfinished learning that could be happening, or just common misconceptions, may not necessarily be unfinished learning, to your point. Any other thoughts or reflections about this process and how it can provide you with that clarity around what the data is telling you about where students' readiness is to engage in these grade level standards?
I have to just say, it is like, I haven't been in a math classroom to teach at this level in a really long time. And I think what's the most challenging for me is, like, I can just work through the problem, but then when I look at a student's work, and I know it's precisely what we're trying to get to, it's hard for me to, like, even put the words together to understand, like, where those deficits are, which also makes me really nervous because these are the same teachers that I'm coaching. And so, like, in OPS, I know the last few years while I was on the elementary side, we were looking at, like, math progressions, and we were kind of talking about how students can choose whatever strategy they use, and we want them to take that strategy and kind of like work through whatever problem. But then this is a different type where it just really seems challenging. So, like, I wrote the problem like I would write the problem, right? Like the first one, $8.50, T equals $42.50. And so then I look at the student's work where she brilliantly broke down how many 850s she could put together to get 42, even though she didn't really do what the problem asked her to do. Like, trying to help them to understand, like, that concept of the equation is just really kind of difficult to explain, I guess, if you will.
So I'm glad you brought that up, because like in that particular student work, I think that's like a quick fix, because the tape diagram, it's a certain number of unknowns to get to that value. And so you could see that the student has the understanding to solve an algebraic equation. They just have to set up the structure to create the equation to then go ahead and solve it. So that tape diagram is a method, because you have 5 sets of those of equivalent values that give you, so that's how you know how many tickets you need at that price. So that, I mean, it's not a structured equation in the sense of what we're used to seeing, but that tape diagram does mimic the structure that we want students to be able to pull out, and leveraging the tape diagram to be able to solve that equation. So that's saying, look at what you did, that is correct. Now, can you see how what you did connects to what the solving of equation is? And it's the exact same thing. And even with the student who did the guess and check, I would argue that the math that they use to solve the equation or to find the answer is the same math they would use to solve the equation. The same thinking, not the exact same math, but the same thinking. So you would just modify or support them to see the connection between how they interpreted that question, and how they can set up and create an equation to represent that same ideal, that same concept. Because the math, the fundamentals of the mathematics is there in that particular problem, if that makes sense. It's just not answered in a way that is being expected based on the grade level standard. But they're on the right track, if that makes sense.
Yeah, I mean, it sounds so easy when you explain it.
But then that's also why, like, the point about having that deep content knowledge is so important, because without that content knowledge, how do you make those small connections? Because one person could look at the tape diagram and be like, oh, that student's way off. Or someone looks at the guess and check and says that student's way off. But one of the first things that students do learn when they're solving equations is how guess and check is one way to solve like a simple equation. It doesn't work when the numbers are super big, but when the numbers aren't that daunting, you can guess and check to find out what the missing value is that'll make the equation true. I know we are over time, but I felt like, I hope you're not upset about that. But I wanted to kind of talk through this because I felt like some of the conversation in the breakout rooms wasn't finished. And I want you to walk away with this idea that this work is like so daunting that it can't happen. We want to lift up this idea of a structured approach, because oftentimes there are some commonalities of standard misconceptions, but there are also nuances within those misconceptions that, rather than teach this whole 3-lesson cycle around solving equations, maybe there's some do nows or some bell ringers that you can do over a couple of days that will get to the same thing, that's more efficient than teaching these same 3 lessons that you always teach prior, before you jump into the equations unit, which is why we're advocating for you to diagnose where students are in their learning, to then provide that just in time and appropriate support to give them access to grade level work. Because my last thought is that in them working through the grade level content, because this standard lifts up all 3 aspects of rigor, they will get the practice over time to become more fluent with solving equations. So if I had a student set up the equation and then go off to the side and keep adding up 850 until they got to 4250, but then came back and said, oh, I need 5 tickets to get to 8250, I'm okay with that, because over time that's developing that fluency so they can do that a lot quicker. Hopefully that makes sense and the bigger picture is there. So like that student has the understanding. They're not as efficient as another student, but they're on the right track, and we want to build and develop that student based on where they are to support them to grow and develop against those grade level standards. Any other thoughts? Or you guys are just like, it's time to go, I need to leave? Any other thoughts? All right. So I definitely always want to do my best to honor time commitments. Just want to finish up very quickly. And so want to make sure we're looking at student work as half full versus half empty. We want to advocate, like, here's what my students were able to show me from that diagnostic, versus here are all the things they don't know based on what the data shows me in the diagnostic. So we want to lean on that asset and positive thinking versus that deficit mindset thinking that we talked a lot about last time. The other thing we want to lift up is this idea of having clear evidence versus leaning in on inferences. So evidence is the student work, what the student did within their student work, if there were like justifications or calculations that were written or that were put on paper, versus, oh, well, I've seen him solve this equation before, or I think he just made a careless mistake. And so the drawback to inferences is at times those inferences will get you to avoid giving that student that support that they need to get them to full mastery. So we want to make sure we're using the data and the evidence to make our decisions versus leaning in on inferences. And a lot of you saw this overall snapshot from Ms. Hutchins' class. And I would argue that if you think about question number 1, for example, this intervention that she would provide would definitely be a whole group intervention, considering only one student got this answer completely right. A couple were almost there, and most of the students didn't have any evidence. So use the data accordingly to determine how you're going to provide that intervention, whether it be whole group, small group, or it be a targeted intervention for super small groups of students based on the data that's there. The other thing I want to lift up very quickly is that if you look at the snapshot, although the majority of the students fall into the category of almost got it or not yet, Ms. Hutchins was still able to lift up some strengths that she saw her students exhibiting from the diagnostic assessment. She was also able to lift up some misconceptions, and that's what's going to drive her support to provide that just-in-time intervention for her students to give them that access to the grade level content. And so what we're looking at is we want to have these bite-sized amounts so they're digestible, and we're leveraging that just-in-time data to provide students that support that they need. And we're actually interpreting the evidence that we've collected from the student data to provide the next steps for providing that, that support. And so one of the things we just want you all to think about is, to what extent is this work happening effectively at your school or in your classroom? And then also, what implications might this learning have on how you support schools or teachers with assessing and diagnosing unfinished learning in your role? So the next time we are together, what we're going to do is we're going to focus on that third key action for acceleration, which is planning and taking action. And our next session will be intentional course supports, which means we're looking at what tier 1 supports we could embed into the regular mathematics classroom that will support all students. And with that, I do want to say thank you. I definitely just want to apologize for going over by a little bit of time. But like I said, I wanted to just kind of unpack some of the things that I heard in the breakout room, so we all walk away with a clear picture of what's a way we can embed this practice into our regular work. And so in the chat, I dropped the links for the survey. Both links will take you to the same place. I just want to say thank you once again. Thank you for staying engaged. You probably had a long day just like I have, but you stuck it through, and we're at the end. As always, I will stick around for a few moments just to make sure if you have any questions, you feel free to ask them. Other than that, just thank you, and please complete the survey. Let us know what worked well today, and let us know what shifts or modifications we can make to ensure that you are having the best opportunity to support your students and your teachers' big picture. So thank you again.